Testing, testing, 1, 2, 3, testing, testing. Let's just see what our latency is today. Hello, everyone. Hope you're all doing well today. Doesn't seem to be too bad. Okay. Hello and welcome. You have found the lecture, which is good. Hopefully the whole posting links to the Avenue thing works reasonably well. Hopefully nobody's been left behind in that particular process. So this will be our first lecture under the new regime of hopefully not having quite so toxic a comment section or a live chat section. I've thought about the process of trying to, regulate this as, I think a good metaphor for it is like a biology metaphor. If you imagine our live stream is like a bloodstream, a troll in the stream is kind of like a virus or something, or like a bacterium. So there are two ways primarily that the body deals with bad actors, shall we say. Number one, the body has skin, so it's difficult for viruses and things to get into your bloodstream because you have skin. And I'm hoping that unlisting the videos is kind of like having skin. And the other thing is that there are white blood cells. So in our case, the moderators that have been appointed for the chat for this channel will be our white blood cells who will act to disrupt the taking hold of infections in the live chat stream. So for those of you who are moderators, please take an opportunity to say hello. I'm a moderator, and aside from that, we'll just get on with it. Get on with it. All right. Oh, and yeah. Oh, well, I thought I had another announcement, but that was for the other class. Sorry, guys. Is chat actually working? Like, are you guys awake? Are you guys here? Is chatting enabled? Okay. All right. Well, I guess it's just me then. Maybe if I reload the page. Let me see if that works. Oh, yes, there we go. We do have chat. Good morning, good morning, good morning. Yes. Cool. All right. Sometimes I just have to reload it on my phone if the chat isn't showing up. I'm not sure why. Having it on my phone is a lot less distracting than having it in the side of the stream, though, so. Good. Anyway, so. Last time that we were talking about the process that's gone through in order to actually execute a C program from source. So just to recap, that process is, number one, you edit the file. 2, it goes into pre-processing. Then it's parsed, assembled, linked, loaded, and executed. And we were just talking about invoking the compiler. So I believe I had already done the bash example of that. So to compile a program, you need to use the following command: gcc simple.c/o. That specifies the output, the name of the output file. We're calling it simple. So GCC knows this is a C file because it's got the .c file extension, or possibly the .h file extension. The first argument to GCC is the file that needs to be compiled. I already talked about that. And what's produced is the produced file is the original program expressed in machine code, also known as object code. Note that this is different from assembly language. For questions about downloading the C kernel for Jupyter, please refer to the GitHub page for the kernel that you're trying to install. To be completely honest with you, I did not install the kernels on the Jupyter Hub system that we're using. Our IT professionals in the department did, who are absolutely wonderful people. So, yeah, maybe somebody else in chat has an idea for you, and maybe somebody in Piazza would have an idea for you. Anywho, so once the compiler is invoked, it goes through a couple of stages. Whoop, there we go. First is pre-processing. The purpose of pre-processing is to get the code ready for parsing and generation. So this includes a number of operations, like removing all of the comments, because obviously the comments aren't going to be executed. So before the file is turned into something executable, the comments are removed. Any macros that are in there are expanded. We're going to get to macros significantly later in the course. Any include statements are processed. Include is essentially the same as import in in Python. So if you again, we're relying on you guys knowing Python. It does a few other things as well. Once the file has been pre-processed, the code is broken down into tokens. This is also known as tokenization. The tokens are arranged. I did this slide already, but that's okay. I'll keep going. The tokens are arranged hierarchically into an abstract syntax tree. This is so. If you imagine a function contains a loop which contains a statement, the function is the sort of top-level construct there. The loop is inside the function. The statement is inside the loop. That's what it means to be hierarchical in a grammatical sense. We then send the abstract syntax tree into assembly, which is used to create a series of machine code instructions which are saved in an object file or a .o file. And then the object files are linked up using the linking process. And then once the object files are linked, you have an executable that you can actually execute. So here is a rough overview of how this process works, a graphic from the textbook. We've got the editor, preprocessor, the compiler, and the linker. These are all of the points at which the process touches the disk, I think. Yeah, anyway. So, compilation does not always go smoothly, as I'm sure many of you will have understood by this point in time. In general, in C, you will get two main categories of compiler complaints. You'll get syntax errors. These occur during parsing if the code cannot be parsed correctly. A syntax error essentially means that you have goofed up the grammar of the language. The easiest example of goofing up the syntax is something like forgetting a semicolon or not having the correct number of curly braces. There are, in addition to syntax errors, there are a bunch of compiler warnings. They will not prevent the program from being compiled, but they will definitely indicate problems with your code. Not all warnings are shown by default, so if you want to see all of the warnings, you have to use the WALL flag when you invoke the compiler. And if you don't want to see any warnings at all, you may use the lowercase w flag. I don't recommend that, though. The types of things that you will be warned about are the use of data types and pointers incorrectly, not using variables that have been declared, or using assignment operators instead of equality operators. We will talk about various compiler warnings that can occur for the various things that we learn how to do in C as we do them throughout the course. So, yeah. Generally speaking, you'll want to pay attention to your compiler warnings. Just because it's not preventing your code from being compiled does not mean that it isn't. It's kind of... There's this thing they say about correlation and causation, that correlation does not imply causation, but it does point suggestively and waggle its eyebrows. The same is kind of true of compiler warnings. The reason that, like, a lot of things that are compiler warnings in C would be straight-up errors in a lot of other languages, and the reason that a lot of these are warnings rather than straight-up errors is that because C must maintain a level of back compatibility before a lot of these good practice sort of, all of these automatic checks for good programming practice became law in programming languages like C++ and Java. Because we have to maintain back compatibility with these, you can't actually prevent a lot of these old programs from being compiled. That's part of the purpose of the C standard. So, a lot of these things end up as warnings rather than as straight-up errors. There's a thing that's said about Linux as an operating system as it compares to Windows. Windows will try to prevent you from unintentionally doing stupid stuff. A good example of that is the recycle bin. If you delete a file that you didn't mean to delete, Windows can fish it out of the recycle bin for you, and that's how you do it. To the question about tutorials, I believe both of our TAs are doing those on Microsoft Teams. But let me just check the syllabus for you quickly about that. Burp, burp. Yep, both of them are on Microsoft Teams. So there you go. What was I saying? Yes, Linux. Okay, so the difference between Windows and Linux is that Linux is an operating system that assumes you know what you're doing, which means that it doesn't provide the same level of insulation against your own stupidity. And that's, a good and a bad thing. If you are a stupid person, then you probably want to use an operating system that protects you from your own stupidity. However, if you are a person who is not stupid and actually does know what you're talking about, it can be nice to do stuff in an environment that doesn't treat you like a child. C is a programming language that doesn't treat you like a child. Whereas in something like, shall we say, Python, if you're, let's say in Python you try to use a function that you haven't defined yet. I know I'm going to use this particular example because I'm working on the topic 3 slides right now, which are functions and recursion. So this is an example that's going to come up in topic 3 actually. So in Python, trying to use a function before it's been defined is an error, right? It will it'll stop execution and say, hey, you didn't define this. I need to know what that is before I actually use it. In C, it's just a warning. So in C, the program's not actually prevented from forming an executable if the function that you're trying to reference doesn't exist in the context you're referencing it in. What it'll do is it'll actually pass that along down to the actual executable itself. So the executable itself will actually flop out, bork up, because you're referencing a function that's not actually been defined. And the reason for that is that it is actually possible to write C programs which use functions which haven't been defined, like in the C program itself. Like there are, like way back in the ancient era of computing, not everything was referenced quite as stringently and strictly. So you'll probably still be able to do it these days. I'm not saying it's good practice, but it's possible. There's going to be a lot of me saying I don't think it's good practice, but it's possible. But anyway, so a lot of stuff that would be an error in other languages is a warning in C. So you should pay attention to your warnings. And it's very easy to write a C program that has hundreds of warnings if it's a sufficiently large program. So if we wish to execute the executable, the command to invoke that in Linux-like environments or bash is // and then the name of the executable. I believe in DOS it's run and then the name of the program, but I'm not a huge DOS user. Once you ask the computer to execute the program, it loads it first and then it executes it. So during loading, the compiled C program is loaded into the system's primary memory, usually the RAM, from the ROM. So the executable is a file that's on your file system. In order to be executed, you have to take it from the file system, drop it into the RAM. Then, once it's there, the CPU can run the program, starting with the first instruction and proceeding until the program terminates. So this is another little graphic about how that goes. You have the disk. The loader takes from the disk and drops into the primary memory the program. Then the CPU and the primary memory interact, and your program is actually executed. When runtime isn't fun time, often your code will contain bugs despite being compiled and linked successfully, even if you solve all your compiler warnings. These are known as semantic errors. Semantic errors sometimes will just straight up crash the program. These are what's known as fatal errors, because they have killed it. Fatal errors include things like dividing by 0, that's a big one, and trying to access memory that doesn't belong to you. This is the dreaded seg fault. We're going to get into seg faults quite a lot when we talk about pointers. Oh, I have a question. What is the bracket ... $$ for? Yes. So this is just my way of saying some stuff. Like, normally if you have a bash prompt, like here, you'll notice you have like your username and the file directory and the name of the computer, etc., all the way up, and then the $sign indicates the actual bash prompt. $sign isn't used in all types of command line prompts, but it is used in bash, which is the one that I'm using, so that's the one that ended up in the lecture notes. Hopefully that answers your question. Is there an emergency termination, like keyboard interrupt in Python? Yes, it's Control-C. I should put that in the lecture notes, eh? Yeah, so if you have a program that is in an infinite loop or something, and you have executed it from the bash prompt or some other thing, if you hit Control-C on your keyboard, that is the universal bash command for terminate process, and it terminates the process. So Control-C, that's a good one to know. Yeah. Yeah, I guess the comp sci guys get a course on how to do stuff like that, but I suppose the Utron guys haven't actually seen a course in like this type of Linux basic stuff, eh? Um, I'm not judging or anything. I'm just I'm kind of at this point reevaluating whether it would be good for me to throw a few more slides in topic 2 on the basis of how to use the bash prompt and stuff like that. Um, hmm. Or maybe that can be a tutorial. Maybe we can cover that stuff in tutorials. It's not like it won't be useful. Anyway, so much for fatal errors. Other errors that can occur don't necessarily crash the program, but cause the result of your program, the output of your program, to mismatch what you wanted the output of your program to be. This is kind of a more formal definition. Yeah, okay, I'll put some slides in then. So in order to know that your program is producing the wrong output, you need to know what the expected result of a program is for specific inputs, i.e., you need to have some sort of specification. Running a program with specific inputs and looking for a correct known output is called testing. Whether you realize that's what you were doing or not while you've been testing the programs that you've been working on over the course of your life, that is what you're doing, even if you don't realize that is what you're doing. So, during runtime, there are a few things that a C program can interact with. If we wish to interact with a C program using a monitor and keyboard, the C program needs to interact with the following. You've got standard input, the standard std_in, which is the standard input stream. This is a place where your computer places keystrokes that are logged for retrieval by programs. So when you type on your keyboard, you are creating keystroke events. The values of those keystrokes are put into the standard input stream. Those keystrokes may then be extracted from the standard input stream and operated on by programs. Generally speaking, these are buffers. So once something is read from the standard input stream, it does not remain in the standard input stream. That's why when you type on a keyboard, it's only one program that grabs the keyboard input. Standard output, the standard output stream is a place which collects things things that programs wish to print to the screen. So when your program writes something like the maximum is 5, this is again a program that I've been working on with respect to topic 3, so you'll see the program when we hit topic 3. That message is put into the standard output stream, and then this terminal environment grabs the output that exists in the standard output screen and converts it to characters displayed on the computer. So, there you go. There's one more of those as well, which is the standard error stream. This is similar to the standard output stream, but reserved specifically for error messages. So, there's sort of a side mechanism to have, because when an error occurs, it does things, depending on the error, like terminate the program. So it's, whether or not standard output will continue to display things that have been, put there by a process that's been terminated is, who the heck knows. But standard output is a little more, it's designed to be a little more permanent, I guess you could say. There's a word I'm looking for that's not permanent. Static? It's a bit more static. How's that? Okay. All three of these streams are emulated or are connected in a more complex manner in environments such as Jupyter and VS Code. So when in Jupyter you execute your code box and it says hello world, Jupyter is, like the Jupyter environment is acting essentially like a virtual machine, emulating the emulating standard input and output by capturing the inputs and outputs that that the C program is expecting, and then providing functionality that looks like that to you, the user. STD out is for printing to the screen. In order to print to a file, you need to open up a file stream, which is an entirely and completely different process. We're not going to get to file I/O until later in the course, probably around topic 6, 7, or 8. I'm not sure, but we have to cover it. It's in the syllabus, and probably it's going to be like a after pointers. We're going to have to cover pointers first. Good question, though. So, this is actually the last slide, second to the last slide of this topic. I will leave you for a moment with the last slide comic. I will give you sufficient time to pause your video player if you wish to read the comic, whilst I load up the topic number 2. Moving right along. I thought the comic was funny. That comic is basically a conversation that I had with my wife a couple of weeks ago. Okay. So, now that we've talked about what it means to program in C, time to start getting into the nuts and bolts. It's time to start learning the frigging language, man. So, throughout this set of slides, we're going to be referring back to Python. Once again, it's assumed that you guys know and are familiar with the basics of Python, and I don't have to re-explain what an if statement is. If you need explanation for what an if statement is, I recommend doing some additional reading from the textbook. The textbook, or literally anywhere else. If you Google it, you'll find way more than you could possibly digest about if statements. So, let's talk about basic constructs. We will cover simple input and output, fundamental data types, some more memory concepts. We'll talk about operators, we'll talk about selective structures, and iterative structures. I know it sounds like I'm going to explain if statements again, but again, this is going to be... Last slide meme. This is going to be focusing on differences between C and Python. So, here is a really simple program in C. I believe I've already done this one on, I've already done this one for you guys. So we've got include stdio.h, int main void, printf, hello world, new line character, and a function main. So let's break this down. Let's talk comments. Comment your code or else. In Python, the octothorpe character designates a single line comment, and that's what it's actually called. It's called octothorpe. In C, a single line comment is //. If you want, you can also use multi-line comments. So in C, if you do /*, that opens a multi-line comment. // closes the multi-line comment. These asterisks in the middle are not actually syntactically required in order to continue a multi-line comment. If they were omitted, that would also work. However, it's like a stylistic thing. It looks better, so I put it in. You'll find that there is no return 0. Return 0 is not actually strictly necessary, but often a good idea. No, class isn't over. So you will find throughout these slides and throughout this course that while I am teaching you basic constructs, I will also be trying to teach you stylistic things and conventions that exist in order to make your programs look nice. If you remember to the first set of slides we had, there was maybe I don't know, maybe we did this, maybe we didn't. Maybe it's coming up. Did we? Okay. All right. Never mind. It's coming up. But it is definitely possible to write a C program that works but is completely unreadable. So so we're going to do some stylistic stuff at the same time. Multi-line comments, very useful indeed. In fact, one thing that's kind of cool, if I can open up a code box for a moment. Nope, not that one, this one. A thing that's fun is you can actually hide an end of comment inside of a comment. So you can, basically you're able to toggle whether something is commented by only including the top, the multi-line comment at the beginning. So comments are used quite a bit in order to like get some of the code disabled. Like disabling segments of code is a very common use of comments. But there are also some guidelines in terms of documentation. So here are some guidelines for commenting code in C. At the top of the file, you should indicate the author, the date the program was created, the date the program was last modified, and the purpose of the program. These are all good things to know. If you don't put them in the top of the file, then, you know, unless the directory structure of your file system indicates what the heck this program was for, which it often can, nobody will know. So there you go. You should comment each function to indicate what its purpose is. This includes any assumptions about the inputs, properties of the outputs, and invariants that will hold throughout execution. So if you're writing a program that finds the median of a array of numbers, it would be good if you said this function takes as input an array of numbers and produces the median as an output. Because, you know, while you can get a certain ways with descriptive function and variable names, it's often better to speak in complete sentences. One thing that's something different from what you would probably be used to in Python is it's often very useful in C to indicate where the end of a function is. There's no sort of pre-baked syntax that requires this, but the thing about C functions is because the language is so low level, it often takes a very long time to say it. Yeah, it's kind of like old entish in programming in C. What's the line? It takes a long time to say anything in old entish, and we never say anything unless it's worth taking a very long time to say. So, unless it's an assignment for this course. Sing! Anyway. So, in C, it takes a long time. It takes a large number of lines of code in order to do anything useful. Even a simple program will often run you, like a very simple program, gets into like 30 or 40 lines of code very quickly. So, you'll very, very quickly realize that not your entire function can't be displayed on the screen all at once, which means that it becomes difficult to know, looking at the tail of a function, what function that function actually is, which might be useful. So commenting the end of a function as the end of function X will make it much easier to navigate your code. Unless, of course, you're using an IDE that does this sort of thing for you, which is also entirely possible. So let's talk about preprocessor directives. Hey! In Python, we access libraries using import statements. The ellipses here indicate whatever the name of the thing you're importing is. In C, we use octothorpe include, angle braces, dot dot dot. Lines beginning with octothorpe in C are called preprocessor directives. If you remember from a few minutes ago when we were talking about preprocessors, the preprocessor, preprocessor directives are processed during preprocessing, as you might expect. Preprocessor directives are, yes, I said that already. .h files are known as header files. Many of C's most important libraries are stored in header files, and you yourself will be able to write header files when we talk about topic 3. stdio.h, the standard I/O library, contains the definition for printf, and much more besides. Adding the line include stdio.h to the beginning of each C program should become an automatic reflex. You should just do it. There's probably no program you will ever write that doesn't need printf, so you should always include it. One might say, "But Mr. Professor, sir, if it's used all the time, why doesn't it include it in the C prelude, like if statements are?" And that's because, frig you, essentially, on the part of the C, the people who designed C. No, that's that's a little bit too dismissive. So C recognizes the difference between functions and constructs, and no functions are included in C by default unless they're explicitly included, because that way there's nothing included that isn't necessary. That's how it works. Ooh, we had a comment, but I didn't catch it before the message was retracted. I guess it had a spelling error. So, terminating statements. In Python, whitespace is used to determine program structure. In C, special characters are used instead of whitespace. In Python, each line contains one statement, unless they are separated by a semicolon character. So you can have multiple statements per line if you put a semicolon in between them. In C, each statement must be terminated with a semicolon, regardless of what line they're on. So, if, for example, I wanted to say I is equal to set 8, int I is equal to 8, int j is equal to 3, int z is equal to I plus j, the thing that indicates that these are statements is not the fact that they are on separate lines. It is equally the same program if all of these things are on the same line. You could have your entire you could have literally your entire program on one line if you really wanted to, because the separations in the programming are not indicated by white space. They are indicated by characters. So that is the same program. We're going to see a very stupid example of this coming up very quickly. Which IDE is this? Oh, this is just Get It. This is like GNU Edit. It's the Linux version of Notepad. It does syntax highlighting, though. Yeah, so statement blocks as well. Statement blocks in Python are indicated by indentation. So the thing that makes this if statement inside of this function definition is the fact that you are now at a different indentation level. Whereas in C, we use curly braces to indicate what things are inside what. So essentially, yeah, that's the long and the short of it. So, a question. What does the void mean in the main function? There we go. So if you put void here, it means that main accepts no arguments. It is possible to pass arguments into a C program by putting arguments here. However, you have to do it in a very specific way because this is C, and this is a thing that we're going to talk about later on in the course. It's not necessary for now, but putting void there, if you leave it blank, it'll default to void. just like if you leave out the return 0, it'll default to returning 0. So, you know, there are some points where you're given a bit of a hand. So if you put a void here, it would mean that it doesn't return anything to any other function, right? Main returns an integer, but if you were to write void does nothing, right? Takes nothing, does nothing. This would return nothing, but, you know, there you go. Yeah. So, where were we? Yeah. So in Python, even these parentheses are not necessary, but in C they sure as heck are. So there you go. So because statement blocks are indicated using curly braces, you don't actually have to follow any conventions with respect to indentation. So white space does not matter in C. So you have this program, which is a, you know, fairly rudimentary C program. This is the same program, the exact same program. So if you, the only exception to this is, I believe, include statements or preprocessor directives. I believe those do have to be on their own line, but you know, I could be wrong about that. So if you notice, this is all of the statements from the previous, with like random new lines and spaces and no lines. Just the white space has been messed up completely. As far as the compiler is concerned, this is the same program as this one. It's like that meme where it's like, what's her face from The Office is looking at two pictures, and it's like, this is one of the pictures, and that's the other pictures, and it's like, what's the difference between these two pictures? She's got the CPP written on her forehead, and she says they're the same picture. That's what the C compiler thinks. So let's talk about the main event. In Python, execution begins at the first line of the script and terminates on the last line of the script. You know, relatively straightforwardly. In C, execution begins at the first line of the main function and terminates either when the execution reaches a return statement inside of main, or when the program reaches the last line of main. So we enter the program. Let me just fix this. Bop, 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 doo-wop, shoop, doop. There we go. So we enter here, and we exit there. Nothing else is nothing else is going to be executed. Just the stuff in main. And a function is only called if it is called from main, or called from something that is called from main, etc., etc., etc. So, yes. If you have a C program that does not have a main function, it will not compile. That is a syntax error. Your top-level file has to have a main function. Your library files that you're using for your C program don't necessarily need to have main functions, but the top-level file has to have a main function. Main is called by default on program execution. Yes, that is a good way of putting it. Well, maybe void main is a thing, but int main is conventional. So, if you try to put regular statements into the global namespace in a C file, that will result in syntax errors aplenty, and I don't recommend it. We will talk about C functions in excruciating depth in topic 3. So don't worry, we'll get there. The int keyword indicates that main returns an integer value. A return value of 0 indicates the program exited normally, i.e. without any runtime errors. Any other return value typically indicates the program executed abnormally, i.e. that errors happened. You can actually look up tables of these error numbers, these error codes, and see what they indicate for various programs. Giving void as an argument indicates that this program is ignoring any past arguments. The void keyword may be omitted. So there you go. These are all things that we've already talked about from the chat questions, which have been very good. I am happy to see that chat isn't completely toxic today. That's a good thing to see. Maybe our active countermeasures are working. I hope so. So anyway, let's talk about printf and the standard output. Buffer, stream, one of those things. So, printing strings should be nothing new, but let's go over it anyway. Printf is the equivalent of Python's print function. The biggest difference is that printf does not automatically append the new line character to the end of a string. So, if you have the following sequence of printfs from one string to another, from one string to the next, everyone loves Lisp. The produced output will be from one string to the next, everyone loves Lisp. Notice that the only new line character that's used is the one that's added explicitly. Cool. Yep. There you go. So that should be relatively straightforward. Incidentally, are there any questions? I'll give you guys a minute to think of any questions that you have, because we're actually making pretty good time on this. Okay, that's good enough for me. Seems like you guys mostly have questions when there's actual code up on the screen, and it's mostly like, what does that do? What does that do? Which is good. That's a good way to learn. Anyway, let's talk about strings! No strings attached. Oh, that should have been my pun for this slide. No strings attached. Anyway, if you've been noticing, I've been sneaking puns into the titles for each of these slides, or as many puns as I can think of. Ooh, is there a C equivalent of Java's print line? Yes, probably. It's probably in the standard library somewhere, but you know, I don't know. Look at the documentation, man. I think there probably is, but anyway. In Python, strings are delimited by either double or single quotes. You could use them interchangeably. Double quoted hello world is the same thing as single quoted hello world. However, in C, single and double quotes have very different meanings. In C, as in most languages actually, Python's kind of unique with this quote equivalency garbage. Double quotes are string delimiters, but single quotes are character delimiters. So in C, we recognize very strongly that there is a difference between a string and a character. Strings, obviously, have lots of characters in them, and a character is just 8 bits, like an arrangement of 8 bits. A character has a lot more in common with an integer than it does with a string. The only thing about strings is that they're composed of characters. So we're going to get into how that works, but ooh, I've got some questions. All right. If you specify that the function returns an int and you don't return anything, does anything happen, as opposed to void main where you probably don't need to run? So it would probably let you do it, but it probably wouldn't be a good idea because you wouldn't know whether, like void isn't really a thing in C. at least as far as I know. The like in something like Python, you have like dedicated undefined or null types, right? I'm probably wrong about this. I don't know. Maybe C has a null type and it would return a null. It's possible, but at any rate, because C is not really strongly statically typed, or C's like the type checking in C is kind of all over the place. Even if it were a null value, what would probably happen is that if you tried to use a null like an integer, it would use what the underlying bit representation of a null is and use that as the integer. So, there you go. You only really have to worry about casting if the things that you're trying to convert between are different bit sizes. But yeah, anyway, so that's the answer to that question. I see I'm just about out of time. So let me just finish off this slide and then we'll go, in order to enter special characters like new line and tab, there are escape sequences, which you probably have seen before. /n is new line, /t is tab, /a is alert. To insert the actual / character, you have to do //, and to enter a quote, a double quote, you use /quote. That inserts the quote character. So yeah, there you go. That is some stuff. Thank you very much, folks, for paying attention to me today. I'm going to go get some lunch, and hopefully you guys are also going to have some lunch, unless you got up like an hour ago, in which case you should get some breakfast. Anyway, thank you very much for your time and attention, folks. I'll see you